In this video, we're going to look at SQL injection or SQL injection, which is, as you probably know, one of the most common and well-known vulnerabilities that we find on the web today. And besides the more basic variant that you may already have seen, there are slightly more advanced versions that will also look. At any rate, SQL injections are a typical input validation error. If we look at a SQL query, it is often in web applications built using the parameters provided by users. For instance, you might create a query such as this one, where we select the social security number from a table in a database of employees, where the name matches some parameter that is provided by the user. So now you're looking up the user's social security number. And that's all good, except that you can provide as a user special characters, such as the tick, right, or the dash dash, which means a comment in SQL, or the plus symbol, the at symbol for variables, and the percentage for wildcards. Anyway, all sorts of special characters that have meaning. Okay, and using those special characters, you can, if you're lucky as an attacker, modify these queries in some ways that the database never expected, that the application never expected. And using that, you can obtain information from the database or change data in the database, or probe the database and find out what it contains. And finally, if you're lucky, you can run commands on the host that you're attacking. For instance, if there is the XP command shell option turned on in the MS SQL server. So what we do and what we're going to assume is that we have some website that contains a form that will be sent to a server, and that server will use that information, that user information, to craft a SQL query. And by manipulating that query, by providing special characters and so on, we want to do things different from what the designer of the database wanted us to do. For instance, if we look at a script such as this one, which is actually the application driving this website for which we saw the form earlier, the script might look something like this, right? Contain at least a function like this. We obtain the username, we obtain the passwords which were provided as part of this form, remember? And then what we see is that we create a query. SQL is a query, and the query will select, from the table of user accounts, the records that contains the record where the username is whatever the username was provided, and the password is whatever the password was provided. So we do this in ASP. We don't, like I think I mentioned this already, we don't really care about the scripting languages too much. In this case, we happen to use ASP, and we connect to the database and perform this query. Okay, and if we find an actual record, we actually obtain the data, we get access granted. But if there was nothing there with that username and password, we actually get access denied. Okay. So what does a database look like? So this was the web part. What does the database look like? Well, the database may look something like this, and it doesn't actually matter, again, which database we use, for now at least. Okay. Well, if we look at the database, then we see that in the user accounts, we have a number of actual users, right? So there's a user Herbert, Lorenzo, Tannenbaum, and they have some, access levels, and they have some secret passwords, some identifiers, and so on. So if we craft a query like in this way, which we saw in the script, in the ASP script earlier, we can provide our user name and our password, and then it will craft the corresponding query to look up that username and password in the database. The problem starts when we start using special characters, tick or 1 = 1 -- for instance. Okay. So here again we see the crafting of the query with the username and the password, and now we enter as a username, this particular set of characters, so tick or 1 = 1 -- okay. And whatever password we want. We don't care about the password. What will this query look like? Well, the query that is now created contains the following. Select everything from user accounts where username equals quote, quote, so empty, or 1 = 1, minus minus, which means start of a comment, and the rest will be ignored. Now, 1 = 1 is true for many values of 1. So in other words, we're going to get all of the records in the database because this will always be true. Okay. So the conditional statement username equals quote, quote, or 1 = 1 will be true regardless of the username. Okay. And -- means that we ignore everything that follows. Okay. So everything after -- here will be treated as a comment. And we can inject these queries, these special characters, in all sorts of different queries, right? For instance, the select statement, where we did a select and where the user equals username or password. So again, another scripting language that we use here. And that's the example that we saw earlier. But we can also do this for insert statements, right? Where we use it to modify this insert into accounts. And we can use that to maybe add new stuff into a table. We can also add it, so modify the query that is used in an update or in a delete. Okay, for instance, where we can use the trick that we saw earlier to maybe delete everything in a table. So now let's look at a query that is going a little bit beyond. It's not super complicated yet, but it's going a little bit beyond the tick or 1 = 1 -- And we're going to do this in an insert query. And we're going to use this as an example to illustrate one of these attacks in practice. And so we said that we're going to do this in an insert statement. So what does an insert statement look like in SQL? An insert will basically have some priority. We're going to ignore that, but it will insert something into a table. Okay, and what will it insert into a table? Some values. For instance, to insert a record in a table, we can use the following query: insert into, maybe user accounts or so, ABC, with the values data, 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 right? So for each of these columns, we now enter data, data, and data. All right. Now, how can we use that in our attack? The example we're going to look at is taken from a deliberately vulnerable web server utility provided by OWASP, I think. And it's a deliberately vulnerable web server, and you can just download it on your Linux machine or your Windows machine. On Linux, it is a LAMP configuration, so Linux, Apache, MySQL, and PHP. Just download Mutility, and you can play with SQL injection. Okay, so the website that we're going to look at will have a username and email field, and then maybe some more stuff that you can submit. Comments in this particular case for a feedback form, and it will show you the outputs underneath. So what the application will do with the form data that it receives here is it's going to use them into in an insert query to put something in a database. Okay, for instance, if you type lol lol lol, the query that we construct in this application will be insert into comments for name, for email, and for comment, these columns, the values lol, lol, lol. Okay, so and then we'll have lol, lol, lol in these three output fields. Okay, fantastic. So what can we do with that? Well, what we said we would do is we would use these special characters, such as ticks, in our queries to maybe manipulate the SQL query string that is crafted. So let's see how that pans out. In this case, we've used a single tick in the name field on the form and some arbitrary strings for the other two fields. And not surprisingly, we get an error message because the query that we've crafted is a query that tries to insert into comments for the column name, email, and comment the values, well, whatever we provided there. And what we provided for name was this single tick. So it now crafts something that and it tries to insert this with a tick, 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 and then a comma. And that doesn't sit well with the SQL server. So the SQL server complains and says we have an error in our SQL syntax. Check the manual, blah blah blah. Okay, but now we've learned one thing, and that is that this server is probably, or this application is probably vulnerable to SQL injection. So let's try something different. And instead of a single tick, we now provide test without the tick at the beginning, and then a tick, comma, and then test one in ticks and test two in ticks, and then a close bracket, and then dash dash. Well, it doesn't really look like dash dash, and this has a reason, right? In MySQL, a double dash requires that it actually has a space behind it. So we now show this explicitly by having a double dash space dash. Anyway, just think of it as a double. But what we've done is we've created in this first form something that will be used in that query, right? So it will do an insert into whatever the three columns were. And what will it insert? Well, a name, an email, and a comment. And the name in this particular case contains values for the three fields already. So really, it doesn't matter what we filled in for the email and for the comment, because all the information that we require, we already find in the name field. So it will try to do an insert and then use the name field. And for the name field, it will use test with an end quote. And then it will interpret the next thing that we find here as the value for the second column, which was the email. And the third one, it will use as the value for the comment field. And then there is this double dash at the end, double dash, space dash at the end, which means ignore all the rest of it. So ignore everything that was filled in here. We don't care. Okay. And it will fill this in. And then if this is reflected to us, so if the website explicitly shows it to us, we should be able to see that now these three values are provided in for the name, the email, and the comment. So something like test, test one, and test two for these three values. Right. So now we're able to fill in these three values in the database. Let's see what else we can do, because what we really want is obtain some interesting information from the database. And we have this insert query. Can we actually get information out of the database with an insert query? Well, it turns out that this is not very difficult at all. And we're going to start with something relatively simple. We want to find out the version number of the database. And we're going to do that by means of a so-called subquery. So note that we ignore the name field here, and the second thing that will be provided and that will be interpreted as SQL is what is known as a subquery. And the subquery in this case is asking for the version number. Okay, and that means that in the email field, it will return this version number. And you can see it's a really old version of MySQL. Now, getting the version number of the database out of your database is fascinating, I'm sure, for some, but what we really want is to maybe elevate our privileges, for instance, by obtaining the password of the user root, okay, from this table MySQL user. And to do that, we can use the same procedure, use a subquery in this second field. Okay. For instance, we can do, ignoring the name field again, we can have a subquery that selects a password from MySQL user where the user equals root. Okay, and then we're going to provide the third parameter, which was for the comment, and then we have this dash dash space dash to ignore everything else that follows. So these are the three values for these three fields. Now, unfortunately, this doesn't quite work because if we try this, the database complains that the subquery returns more than one row. Now, how can we fix that? Well, what we can do is use all the things that we can do in SQL to bypass this problem. And one of the things that we can do in SQL is limit the number of results that we get. For instance, we can add limit 1, right, which means we only get a single row. Or if we want to be a little bit pedantic about this, we can make this limit 0,1, which means we're only going to return one result, right? And of all the results that we have, we're going to take the first one, so the one at offset 0. So now we only get a single result. So if we do this, we obtain the value of the root password, or maybe this is the hash of the root password, in the email field. And if this is reflected back to us on the website, that's fantastic. We actually just obtained our major victory. Now, in reality, the example might be a little bit oversimplified, and in reality, you don't necessarily see everything reflected back to you. So let's look at that same example, or pretty much the same example again, but now where we have to look a little harder to see it reflected. Not very much harder, but just to illustrate the principle. And again, we're going to have this insert query, which in this particular case will insert into the accounts table a username, a password, and a signature. Okay, and we can provide data there, and that those three fields will then be given those values. Now, assuming that this application is indeed susceptible to SQL injection, we can try the same things that we tried earlier. For instance, filling in for username something like this, containing three fields to also contain the password and the signature. So in this case, we had username, password, signature. We provide the values in the first field for the username, the password, and the signature. Okay. And we don't really care what is here because we use this dash dash space dash to ignore everything that follows these three values. And hopefully these three values will be used to initialize the password and the signature. Okay, so if this works, and the application says that it created an account for name, password, signature, one row inserted, that is in principle great. And it also means that if this is what the application outputs, it means that it reflects the name, the username, back to the user. And having data reflected back to you is really useful, because if you want to obtain some information from the database, it needs to be sent to you. Okay, so this is in principle good, but we have still an issue here, because if we want to use this to obtain the MySQL version number, because we think this is fascinating, we have a problem, right? Because in principle, we get the username reflected back to us, but it's not something that we can easily control. After all, in the query that was created, there was a tick there, which we do not control. Okay, so we cannot obtain anything other than this name, pass, sig, as is, as we entered it, rather than if we were going to put a subquery here it would not be created as a subquery. It would not be interpreted because this first tick we do not control. So what can we do? Well, what we're going to have to do is look to see if any of the other data is reflected somewhere on this web page. So does it actually reflect the password? Well, probably not, but maybe the signature. And we see that this is indeed the case. We have on the web page not just the username, we're logged in as user, but also the signature reflected on the page. And that means that if we're able to have a subquery executed as part of the signature, this will actually be shown to us as users. Okay? And that's exactly what we're able to do. So what we can now do is the same trick that we did earlier, but now with a third field, and we put our subquery there, select version, and this select version creates a new account for whatever the name is, the full 3 values that we added there. But the signature is reflected on the web page, and the signature is used as actual SQL statement, as a subquery. Okay, so now we see that this is indeed an old version of MySQL. So great. But like I said, we want something better than the version number. So we do the same thing that we did earlier. We now, in the third component of our username, we add our subquery to select the password for MySQL user, where user equals root. And we see indeed that this is reflected back to us as the username, test1, but also the password or the hash of the password of the root user. So now that we understand what SQL injection is all about, I think it's time for the obligatory Bobby Tables XKCD comic. And it's one of the most famous XKCD comics, and I'm not going to explain this. It's just all about somebody who has named their son Bobby Tables, or rather Robert Drop Table Students, and this is interpreted by the database as a legitimate query, and it erases the values in the sort of student records of that year. Fantastic, and it basically re-emphasizes the lesson that you should sanitize your database inputs. Now, you may think that the Bobby Tables example is not very interesting because you knew the comic already. What is interesting is what I refer to as database exploration, where we try to find out whether or not a database is susceptible to SQL injection, and if so, what the properties of the tables are. How many columns are there, and what are the types of the columns, and so on. Now, to find out whether a database is vulnerable, we can use a negative approach or a positive approach. And the negative approach tries to use these special characters to create something, a query, that will generate errors. And that's the example that we saw previously in the video, where I used a single tick for the username, and it generated an error. A positive approach does exactly the opposite. So now we use these special things to create something that does not cause an error. For instance, we provide some numbers that are combined with a plus or so to get a query that amounts to the same thing as the sum total of it, right? So 17 plus 5 instead of 22. Or indeed, when we provide string concatenation, such as the example that is shown here, we have tick tick and foo instead of foo. Does it actually generate the same result? Okay, no errors, but still an indication of vulnerability. Now, if this is vulnerable, we want to go further. We want to find out, what exactly is in this table. How many values are there in this table, and what are the types of these values? For instance, you can probe for the number of columns in a query by using progressively longer null columns until you get the right results. Okay, and we do what we use for this is the union. So if we have a query and it uses our our parameters, so that it's vulnerable to a SQL injection. We can use union select null to see whether or not it combines with union. So SQL union will only match if the number of columns is the same. So if that doesn't work, we do union select null null, and then we do union select null 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 until we actually get the desired result. And then we know the number of columns. But the number of columns is only the first step. Now we want to know the type of the columns. And there we use a similar trick. So now we know the number of columns, but now we're going to find out whether or not the first column is a string, right? Is that the type of that column string? Well, what we can do with that is do a union select with just a value for the first column, and then null null for the other columns. So the other columns are sort of the wildcards that will match, but this will only match if the type that you're doing the union with is also of type full. Okay, and then you do this for the next column and the next column and the next column until you know all of the columns that are of type string. And you can do that for other types also. And just to be clear, we can combine these things, right? So we can select everything from our, I don't know, what was a user accounts table where username equals quote quote or 1 equals 1, and then do a union select with null, or do a union select with null 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 null. And then once we've determined the number of columns, we can do this with a union select with a string and null 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 string null, and so on until we've also determined the types of these columns. Next thing that we want to know is maybe names of columns or names of databases. Well, for this we need to rely on database specific tricks. For instance, for Oracle database, we can use the user objects table to extract information about the tables corresponding to an application. Or the user table column table, which can extract the names of the columns associated with the table. Okay, similar tricks exist for MS SQL, MySQL, where we can select the table scheme, the table name, and the column name from the information schema, where the table is, etc., etc. So this is all very database specific, but we can use this because we can simply do subqueries. Okay, so far we've assumed that there's no escaping, so none of the user inputs are properly validated or escaped. But what if they are? What if the quotes, for instance, are escaped by means of double quotes? So that whenever you do select, it's escaped with the quote here, it will actually be double quoted. The result will then be it's escaped with the appropriate single quote. Well, even if the application escapes these single quotes, you can still do SQL injection attacks, so-called second-order SQL injection attacks. And the nature of second-order SQL injection attacks is that the SQL code, the SQL code, is injected into an application, but it will only be used, so the SQL statement will only be invoked at a later point in time. Okay? So it's stored into the database, for instance, in a guest book or statistic page or so, and used at a later point in time. Okay? Now, even if the application then escapes these single quotes, second order SQL injection might still be possible, because then your application obtains this data from the database and uses it to build a query. For instance, an attacker may set the name to John tick dash dash, and then the application may safely escape that with dash and then the existing dash there. So there's two single quotes. But now if at a later stage the attacker convinces the application to obtain this from the database, for instance, when the attacker wants to change the password for its username, okay, and set a new password for the victim John, what will happen is that update users set password equals whatever, where the database handle username equals, and then here it comes, tick John tick dash dash. So this is obtained from the database, used to construct a query, and again we have this the same problem. We call this second order SQL injection. Let's have a look at an example. And the example is just a toy example where we have a website that allows users to specify something favorite. So in this particular case, favorite search criteria. And then you can, this is stored in the database and you can select from your favorite search criteria and do your search again, for instance, right? Now, what we are going to assume is that there is a possibility of a second order SQL injection. So what the user will do is type as the favorite search criteria, tick semicolon delete orders semicolon dash dash. The application looks at the input and it's not stupid, so it escapes out the apostrophe, so that the SQL statement that it will use will look like insert favorites, user ID, and then there's a friendly name, for instance, Herbert or so, and then the search criteria. Okay. And the values for that are, 1, 2, 3 user ID, and the friendly name for this thing is my attack, and then it properly escapes the single quote here. So we have double quotes, two single quotes there, and delete orders, and everything is fine. Everything is fine. However, at a later stage, this information will be used. Okay, so everything is sanitized, but still there is a problem. Okay, because at a later stage, the user will use this favorite search. In other words, will use the value that is in the database, and it turns out that the application uses that value to create a new query. And we see this here, right? So what we do here is we get the user ID and the friendly name, so my attack and 1, 2, 3, and we use that to do a search in the database, so with the user ID and the friendly name, to obtain the criteria. So we select the criteria from the favorites table where the user ID equals whatever we provide, UID, and the friendly name is whatever we provide, the friendly name. And then we execute this this query and we gather the results in the criteria. Now the criteria will have this problematic value, and then once we use that again in a SQL query, so we actually construct a new SQL query with the results that we just obtained from the database, from the criteria database, we again have the same problem of a SQL injection, because what we have provided as the criteria earlier, right? So let me go back to that, is ticks semicolon delete order. So now we're using this to craft this query string, and that of course creates exactly the problem that we saw earlier. So select star from product for product name equals, and here we have our problem, right? Tick, so colon, single quote, semicolon, delete order, semicolon, and ignore the rest. Okay, back to SQL injection. So this is a second order SQL injection where we use the value that we obtained from the database to craft another query string, and that is still generating this SQL injection problem, despite the fact that we originally sanitized all the user inputs. Okay, so this is clearly great for the attacker and really bad for the security of our system. But as we saw in the examples that we've looked at so far, much of this was caused by the fact that we had error messages, SQL related error messages echoed back to the attacker. And the question is it enough if we simply squelch all of that? And the answer is no. So in the case there is no output, no error message from the application, we can still do SQL injection or SQL injection attack by means of a blind SQL injection. Okay, so it's not enough, and we're going to show an example of a news site where, just as a arbitrary example, there are press releases, and you have press releases that are accessed with an identifier. So if you want to have press release number 5, you provide identifier number 5. And this leads to a SQL query being sent to the database, and the press release being echoed back to you. So in this case, we're assuming that there's no feedback coming from the application. So what we're going to do is use a trial and error approach, where we inject something that that should work in case of SQL injection vulnerability, right? So what we're going to do is we're going to try, looking for press release 5 and 1 equals 1, which, if you're vulnerable, should lead to the exact same press release. And so no error messages, you're just getting the same result back. Okay, so ID equals 5 and 1 equals 1 is something that will lead to the exact same press release being echoed back. And now we can start probing, right? So when we're testing for the vulnerability, we may know that 1 equals 1 is always true, but we can now also use other statements to see whether or not we get anything different, or whether we can still have the same, right? For instance, what if we try to guess the username, right? So press release 5 and username equals, Hacksaw in this particular. If this is true, if we're getting the same press release, it means that we guessed the username correctly. And you can use this and also add subqueries and functions. You can also try to extract the database table character for character. Okay. So what is a proper solution to deal with SQL injection? Okay, well, first of all, you should never allow client-supplied data to modify SQL statements, right? So crafting these strings with, these query strings with user-supplied data is very dangerous. So you can try to, always properly escape this and make sure that everything is removed from the user input that could be used for SQL injection. But a much better approach is to disallow it to begin with, right? So really fully remove it from the attacker's arsenal. And you can do that by means of stored procedures or prepared statements. So stored procedures are essentially, code where the application sits isolated from SQL, and all the SQL statements are then these functions, these procedures that run on the database server. Prepared statements are a little bit different, so these are compiled into SQL statements before you add the user inputs. I'm going to show some examples of both of these. Okay. So stored procedures, if we had an original query where we tried to select some stuff from press releases where the ID equals something that you get from user input, okay, this was dangerous because now you're crafting this SQL query string with user input, untrusted user input. Okay, so what we do instead with stored procedures is stick this in code at the database server. So there's a procedure now at the database server to get a press release. And the procedure is just like a regular procedure in a normal programming language, right? So it has parameters, so an in parameter of type integer. And you can provide that integer, and then it will do this select from the database, but it will not craft a string with that. That could be interpreted as some subqueries or something that modifies the original SQL query string. Okay. So instead of string building, you simply call the stored procedure. So for instance, if we have Java, we can connect to the database with a call to do a get press release, and the parameter that we provide is now the user input. But it's a parameter provided to a function. It's not a query string that is crafted. Okay, so that's already much better. And these stored procedures are, just to emphasize this, just like regular procedures, right? So they have name, they have parameters, input parameters, types, they have scoping blocks, right? So here's a beginning of a block where we declare variables, we have control flow in these procedures, we have a variety of things that we can do, also SQL statements. So it is really just a procedure. So stored procedures really solve this problem of SQL injection, assuming you do this pervasively. And the same is true for prepared statements, which are not so fancy as these stored procedures. They don't have all of this. Prepared statements are just that, statements that are prepared in advance. So here we have a prepared statement that will do something with a select from a table users where there has to be a match of these two items. So the username has to be something that is provided as a parameter, and password has to also provide match what is provided as a parameter. But you separately add that as a parameter, and so you don't craft from scratch this query string. And both of these, prepared statements and SQL injection, will actually take care of the SQL injection vulnerability. So let us also look at a prepared statement. So in this case, we're going to look for a district corresponding to a city, right? So maybe this is in a country where you have cities and districts, and the idea is that we query the database. So we prepare a statement to select the district from a city, right? And the name has to match. So this statement is now prepared. There's no modifying this anymore. This is the statement, and it binds a parameter to it that is provided by the user. So the parameter is provided not to modify the query in a sort of a string building exercise, but rather as a proper parameter. And then we execute the statement and get the result, right? So now we obtain the result in the district variable. Okay, and that means that that we now have the same sort of functionality that we could have prepared, that we could have obtained in the regular way with string building, but without the SQL injection vulnerability. And of course, SQL injection has been around for so long now that you would think that at least all the normal companies, the professionals, would not make this mistake anymore. And you'd be wrong, because just a few years ago, this article appeared in the Register. So this is just an illustration that it still happens relatively frequently. Okay, and it was about the SQL injection vulnerability, and it explained. That's why I'm showing it exactly the problem. And I think it's best if you have a look at this yourself, figure out whether you can spot the SQL injection vulnerability. That, in the slides, it actually indicates where the problem is. It's the path variable, so the path parameter that is used in a way that allows for a SQL injection. But without me spelling it out, I would like you to look at this code and not read the description that goes with it, which actually explains the vulnerability, but rather see if you can figure out yourself why the use of the path variable can lead to problems. And like I said, it will be explained carefully on the next page, and also on the actual page with the code to some extent. For now, I just want to close this video on SQL injection. We've seen that SQL injection can be relatively complicated. It's caused by user inputs not being properly validated and then used in building a query string. And unfortunately, it may be more complicated than you think at first sight, because even if you escape the problematic characters, such as the tick character, it may be that there is a higher order SQL injection vulnerability, something, say, a second order vulnerability, which is where you properly escape characters, and then data gets placed in the database and then retrieved from the database and then still used in a query string, and you would still have a SQL injection vulnerability. So we've seen all of that, and then we've also seen that to solve SQL injection, you can use things like stored procedures and prepared statements. Okay? And that's all that we wanted to say about SQL injections.